Hi everyone, my name is Chengcheng, and I'm an assistant professor at Mendoza College of Business. Today I'm going to talk about how to improve drinking water access in rural areas of sub-Saharan Africa. This is a joint work with Rod, Kurt, Jorge, and Alfonso. Worldwide, there are still over 700 million people who do not have access to clean drinking water, with the majority of them living in rural areas of sub-Saharan Africa. Over there, people's main source of clean drinking water come from hand pumps built by many local NGOs. This is an example of a hand pump in Malawi. What you do is you pump the handle in the back, up and down, and then water from underground will come up. Unfortunately, it is estimated that 1 in 4 hand pumps are not working at any given moment. So in this research, we study how NGOs can operate a water point maintenance program to keep the water flowing. There are usually 2 types of services needed. The first one is called preventive maintenance. So this is done before any real problem arises. The water point is still providing water. It involves replacing some of the fast-wearing spare parts, such as shown in this picture. The second service is called a major repair. So this is when there's no water flowing at all. A major repair usually involves replacing the broken pipes, which is very difficult to do and much more costly. This research project is field-based. We conducted 2 field research in Malawi and in Ethiopia. We also collaborated with an NGO in the Central African Republic. So together from these 3 NGOs, we collected close to 50,000 water point functionality data. Based on our field research and NGO collaborations, we studied the following 2 research questions. 1. How do the NGO's current maintenance practices compare to a comprehensive maintenance program in reducing water point downtime? Second, how does the availability of functionality information relate to NGO's maintenance visitation approaches, budget constraints, and ultimately water point downtime? To study these research questions, we built a Markov decision process to study which cluster of water points to visit in each time period to minimize water point downtime and the associated logistics cost of traveling and pulse replacement. We applied this Markov decision process to the data we collected from the 3 countries, and then we conduct additional numerical experiments to complement our results. We found that comprehensive maintenance service with an optimized schedule significantly reduces water point downtime while keeping the logistics costs at approximately the same level relative to current practices in the field. Second, the relative performance of different maintenance visitation policies not only depends on the availability of functionality information, but also on the repair demand. Lastly, when NGOs prioritize cost reduction over water point downtime, collecting additional functionality information has very little impact on the cluster visitation schedule and on reducing downtime and cost. Our research makes several contributions to the academic literature. First, we provide one of the first analytical studies of preventive maintenance in a humanitarian setting. Our research extends the reliability theory to new social contexts. We further provide multi-country evidence that preventive maintenance can significantly reduce downtime without a substantial increase in logistics cost. We also provide several actionable managerial insights to NGOs operating a maintenance program in the field. They can use our results to raise donor awareness about the importance of preventive maintenance alongside the construction of new water points. When these NGOs are faced with resource constraints, they should prioritize reducing repair costs, such as a more efficient spare part sourcing, enhancing hand pump reliability, such as using higher quality spare parts, and expanding their repair capacity, such as expanding their mechanic team, rather than focusing on collecting additional functionality information. Thank you.